Conduction, convection, and radiation. The concept of heat fills our lives. We see it as we heat our dinner to the perfect temperature. We discuss it involving the temperature outside, determining what we wear, or even if we go outside sometimes. When winter begins to approach, we may turn the heat on in our houses, and when spring comes, we often turn it back off. We also know that our bodies are able to be frozen or burned by touching something too cold, such as dry ice, or something too hot, like a boiling pan of water. What exactly is this heat that dominates our lives? It is basically the amount of energy an object has. It is dependent upon the object molecules and the speed at which they are moving. We can use water as an example. In an ice cube, the molecules are packed tightly together, basically vibrating in place. As the ice cube melts and becomes a liquid, the molecules begin to slide past each other and move around a little bit. Then, as we heat or boil the water to turn it to a gas, the molecules begin to move very quickly and freely. These molecules give the object kinetic energy, which is where temperature becomes involved. Temperature is defined as the average kinetic energy that the particles in an object have. An object with a larger amount of particles moving around will have a greater temperature. With this introduction to heat, we now want to study the transfer of heat. We know that heat is transferred because touching a hot stove burns us, lying out in the sun makes us hot, and putting a marshmallow over a fire roasts it. Is there a difference in the way heat is moved from one object to another? The three methods of heat transfer that will be discussed in this project are conduction, convection, and radiation. Conduction is probably the heat transfer that most people think of when discussing this topic because it is the most common form. It is a transfer of heat through the direct contact of two objects. It is dependent upon temperature gradient, the size of the objects, surface area of objects, and also the physical properties of the materials of both objects. Temperature flows from hotter areas to cooler areas, or in other words, from objects with higher kinetic energy to objects with lower kinetic energy. This is where we see a very important term, thermal equilibrium. It is the endpoint of this heat transfer. When the two touching objects are no longer exchanging heat energy with each other, they have reached thermal equilibrium. As we would assume, the larger the object being heated is, the more energy and time it will require to be heated. Along these same lines, larger surface areas will lose heat quicker than smaller ones. Metals, such as silver and aluminum, are very good conductors. Glass, rubber, wood, and plastic are considered insulators, for they do not transfer heat as quickly or efficiently. This is because they do not have free electrons like metals do. Those free electrons help move the heat by transferring it to other electrons near them. There are many examples of conduction in our everyday lives. When cooking dinner at night, a mother places an unheated pan on the stove and turns the stove on. Within a few short minutes, the pan becomes too hot to even be touched. This is an example of conduction. Pans are often made of iron because it is a good conductor and makes cooking quicker and more efficient. Another example would be a kid playing outside in the snow on a cold winter day. He decides to make a snowball and hold it in his hand. The snow soon begins to melt. This is due to conduction. The body heat from the little boy's hand is transferring heat or energy to the snowball, causing it to melt. 5 months later, it is now summer, and this little boy goes out to play barefoot. It is very hot outside, and he crosses the black pavement to go to his friend's house. The direct contact between his foot and the asphalt burns his feet, so he begins to run. A fun fact I learned when researching conduction is that although metals often feel colder to our hands, they are not actually colder. They feel this way because they are such good conductors and are pulling the body heat out of our hands. Convection is a second type of heat transfer I will discuss. It involves most of the heat transfer with liquids and gases. Liquids are not normally good conductors, like many solids are. As we know, hot air rises, and fluids flow from higher temperatures to lower temperatures. As a substance is heated, it will begin to move away from the substance that is heating it, and will take the gained energy with it. This is because, as the particles are heated, they expand and become less dense than before. Thinking about boiling water, the hot water at the bottom of the pot will rise, while the cooler air at the top of the pot will sink. This is the pattern of circulation in boiling water. There are many everyday examples of convection that we may not be aware of. The most obvious example is boiling water or a cup of coffee. If the cup of coffee sits on the desk for enough time, the heat will rise out of the cup and into the air. The coffee will no longer then be warm. Another example would be an ice cube melting. If it were in someone's hand, conduction would also be involved. We also have convection, though, as the heat melts the ice and flows into the air. Another good example would be a mother preparing dinner for her family. She gets the meal out of the freezer and begins to let it thaw. She places the dish in the sink and begins to run cold water over it, which does not seem smart. However, this actually causes the heat to be transferred into the food faster. Radiation is the final term that I will discuss. This transfer of heat is different because it is not through direct contact of solids, nor is it through movement of water or air. It is a transfer of heat through magnetic waves. In Henderson's article, he discusses the term to radiate, which helped me understand the concept of radiation. To radiate means to send out or spread from a central location, which is a quote from the Physics Classroom article from Henderson. From this, we learn that in radiation, there is an origin from which the heat is radiating out into the areas around it. Hotter objects will radiate more heat than cooler objects. Different temperatures will result in different wavelengths. Cooler objects produce infrared waves, while hotter objects produce shorter wavelengths with higher frequencies, such as a toaster. Radiation may be harder to see and understand, but we can still find numerous examples in our everyday lives. In my opinion, the most obvious would be the sun heating the earth. The sun is the origin point, and it emits electromagnetic waves to heat the earth and keep us alive. Another example would be a tanning bed. The ultraviolet lights in a tanning bed radiate the individual's skin and cause it to bronze or burn, perhaps. Another frequently used example would be a doctor using an MRI scanner. These scanners use two strong magnets and radio waves to create a defined picture of the organs and tissues inside of the human body. Doctors often use this to diagnose and treat patients. Light bulbs, cell phones, and computer screens are all frequently used objects that involve radiation as well. Another example would be an individual at a bonfire. His hands become cold, so he goes and places them over the fire. They are almost instantly warmed, even though he did not touch the fire or see anything occur. This is considered thermal radiation. The point of origin is the fire, and the electromagnetic waves are carried through the air until they reach the insulator, which are his hands. His hands then absorb the heat energy and become warm. Heat controls many areas of our lives, and it is constantly being transferred to and from objects and people. It determines the clothes we wear, the temperature of our houses, the food we eat, and even the activities we participate in, depending on the weather outside. It can be transferred through conduction or direct contact of two solid objects, such as a pot becoming hot after sitting on a stovetop. It could also be transferred through water, air, or other liquids and gases through convection. The circulation of boiling water is a common example of convection. The third way it can be transferred is through radiation. Although radiation is normally unseen and possibly hard to understand sometimes, radiation does occur in many areas of our lives. One obvious example is the sun heating the earth. We know that we would not be able to live on the earth without the sun heating it. Another obvious example would be a tanning bed. Many people discuss the possible unhealthy benefits of a tanning bed through the rays and the radiation that is being put on the person. Without heat energy or the ability to transfer heat, we would not be able to live at all. It is a concept that we are not very aware of, especially considering the fact that it keeps us alive. I have 4 works cited here on this page, and another page with 4 more. And that is the end.